Hello there. Today we're going to be looking at 8.3, multiplication properties of exponents and crying babies. Want to remind you that in the last video there was a whole slew of properties that you needed to know, and this is just a repeat, so you should already have this property. Basically, wow, awesome. Okay, basically, when you are multiplying two numbers where the bases are the same, you add the exponent. So I'm just going to give you some examples here, and we should be able to get through this fairly quickly. Notice that here the base is 11, and the exponents are 4 and 3, so according to the rule, I would get 11 to the 4 plus 3 power, which is 11 to the 7th power. And no, you don't have to know what that is on top of your head, but you have this little thing called a calculator, and you just go 11 to the 7th power, and you get a really big number. 1, 9, 4, 8, 7, 1, 7, 1. Blah, blah. 19,487,171. So there you go. By the way, if you don't know how to make the exponent, there's a little button on your calculator that looks like this, a little caret key. That raises it to a power. So there's a square button and there's a cube button on the calculator, but after that there's no 4th button, there's no 5th button. So if you want to the 7th power, you have to hit the 11 and then the caret key, and then the 7. And then that'll get you what you need there. So just so that you know. What about B? B says they're all the same base. So I'm going to get 2 to the 5th plus 2 plus -1. So I'm adding all of those together, which is the same thing as 2 to the 5 plus 2 is 7, and then -1, so eventually I get 2 to the 6th power, and 2 to the 6th power is another big number, but not as big as that one, 64. Okay, it's a big number, it's bigger than 2, right? You're laughing at me, isn't that horrible? Anyway, 64. Then we have 5, again, same base. So I get 5 to the -2 plus 2. We're adding the 2 exponents. And in this case, you will notice that you will get 5 to the 0 power, because -2 and positive 2 is 0. So remember that before we learned that e to the 0 power is 1. So there is my solution. So now you can try these 3 on your own. Have fun at it. And we'll continue. And now we have pretty much the exact same thing, only now my bases are not numbers, they're variables, but the same thing is true. I know, it's so hard. So that's to the 1 power. So we have x to the 1 plus 2 plus 4. All 3 of those exponents. So we're going to get x to the 3 plus 4, because 1 plus 2 is 3, last I checked. And that would be x to the 7. Now because we don't know what x is, that's just how we leave our answer. X to the 7th power. Over here, it's going to be very careful that there are no parentheses around the 2 and the n. So this 5 exponent only attaches to the n. So do not think this is 2 to the 5th power. This is just 2 times 3. So there's the 2, there's the 3, and then it's times n to the 5th times n to the -2. So these are the only ones that have the same base. 2 times 3 is 6. But here you're going to get n to the 5 plus -2. Which is really the same thing as 6n to the 5 minus 2, which is 6n to the 3, because 5 minus 2 is 3. So that would be my final answer for that. Alrighty? So again, just be careful that these little guys are just regular numbers that you can multiply outside of that. Okay, so now you're going to try this guy, and then we're going to go here, and we're going to do a mix of situations here. What's happening in these problems is that the c's are the same base, but the d is not. So we want to, first of all, simplify c to the 4th and c squared, which would be c to the 4 plus 2, which is c, oops, why did I put a 6? I know why I put a 6, because 4 plus 2 is 6. So you have c to the 6. So what you really have now, if these two are combined to c to the 6, then you have d to the -3. You will recall from the previous lesson that when there's a negative exponent, you move it to the bottom. So c to the 6 over d to the positive cube, and that would be your final answer. Over here, we have a similar situation to the previous example, where the 5 and the 3 are not attached to the exponents. So I can very easily go 5 times 2 times 3. Oops, sorry there. If y'all can exit quietly. 5 times 2 times 3. That takes care of that, that, and that. And now I have x to the 1, x to the 8, y to the 4th. Okay, so these two here are the same base, so I can add those exponents to get 9, because 1 plus 8 is 9. My y to the 4th will stay, and then 5 times 2 is 10, and 10 times 3 is 30. So I get 30x to the 9th, y to the 4th as my final answer. And then you can try these examples here. And then we have one last example for you. And we did something like this in the last lesson where you're multiplying two numbers that are in scientific notation. So basically to do this, I'm going to go 7 times 4, which is 28. Awesome. And then we're going to get times 10. And if you have 10 squared and 10 to the 5th, you're going to add, because those are the same base, we're going to add the exponents to 7. And that would be our answer, but this is not in scientific notation because the 28 is not smaller than 10. So this would actually be 2.8 times 10. And when you move to the left, you want to make sure that you are adding, or not adding, but checking or fixing your exponent there. So that 7 should become a what? An 8, because we're adding 1 when we go to the left. So that is finally in scientific notation. And now you can do that little guy, or 3 little guys, and then you will be done with this lesson. Thank you for watching.